going to describe a very important component of the system, which is the filtration membrane. Okay? The filtration membrane is playing the pivotal role in, cleansing of blood and yeah. So here in front of you is a drawing showing a fenestrated glomerular capillary, and that has been wrapped around by the modified or specialized cells, epithelial cells of the visceral layer of Bowman's capsule, the podocytes. These podocytes are having, processes, foot processes, and these foot processes are, intertwining with each other, creating slits, clefts or slits. These are known as the filtration slits or the filtration pores. I told you that the fenestrations of these glomerular capillaries are not covered by the diaphragm, but there is a membrane which is, upon which the podocytes are resting, which is known as the glomerular membrane. Now, if you move your gaze from this drawing to this is the, blown up image of a filtration membrane, which you can only observe under electron microscope. So these are the foot processes of the podocytes. They are resting on a membrane, which is the visceral layer, or it's also a part of the visceral layer of Bowman's capsule. Here is the blood vessel, or the capillary, with all its fenestrations. The epithelium, which is simple squamous type, it's also known as the endothelium. The endothelium of the capillary is also resting on a membrane, which is known as the basement membrane. So a membrane which is a part of the visceral layer of Bowman's capsule, which is holding these podocytes, and the membrane upon which the endothelium, the simple squamous cells of the endothelium are resting. That is the capillary basement membrane. So there is a Bowman's capsule basement membrane and a capillary basement membrane. Together, they clumped up together and form a single layer that's known as glomerular basement membrane. The glomerular basement membrane is a fusion of the basal lamina of capillary and the basal lamina of the podocytes. Okay? This membrane is just semi-permeable. It's not allowing all the things to come out. We know that these pores are very big, and they are so big that they can allow even proteins. The large molecules of proteins can also get out through this fenestration. This is the inside of the vessel, and this is the space, which is known as the urinary space or filtration space. What happens is this basement membrane is mainly made up of anionic glycoproteins, negatively charged. So most of the proteins present in our blood, they are also negatively charged. So the negative of the basement membrane, or glomerular basement membrane, will repel the negative of our polyanionic proteins. Okay? This is how the ultrafiltrate, which is the, once the blood enters the capillary or the glomerulus, only the plasma-like fluid will get out of the blood vessel, the lumen of the blood vessel. That is ultrafiltrate, but it doesn't contain proteins. It's not supposed to contain proteins. It's laden or loaded with the solute, but not the protein. Okay? So again, I would repeat the configuration or the structure of the filtration membrane. It's important to understand. Made up of the capillary endothelium, basement membrane of the glomerulus, which is the fusion of basal lamina of capillary and the basal lamina of podocytes. And also on top is the visceral layer of the Bowman's capsule. So three things are making up the filtration membrane: capillary endothelium, glomerular basement membrane, and the visceral layer of Bowman's capsule.